Hey,
Hello, we're live.
excited to
Hello,
be
everybody. Yeah, I'm Amanda. I'm on the marketing team at Optimism. I will be in the background. So if we have any technical issues, it's my fault.
here.
There won't be because everything is seamless as always. But I will hand it off to you both to do your Supersim training.
Awesome. So
Thanks,
we'll
Amanda.
start. Yeah. Welcome, Justin, and excited to be here. We'll start off with a round of introductions. I'm Hamdi at the Optimism Collective, focused on DevX, Superchain DevX specifically.
Heck yeah, I'm Justin. I'm the founder and CEO of an engineering firm called Conclave. We managed the recent Superfest campaign, if you participated in that. And I've been engineering DeFi solutions for close to 4 years with a team of ranging anywhere from 20 to 40 over the period. So really happy to be here and happy to get everybody building interoperable solutions so that they can make our lives a little bit easier.
Awesome. Excited to have you here. So let me go ahead and share my screen.
We're getting fancy today. We have a nice deck for you all. So make sure that you post any questions or comments, whatever, and I will read them to Hamdi so he can give us some good answers.
Awesome. The deck should be up now. Can you see it?
You're good.
Awesome. Yeah, welcome everyone. So this is going to be our Supersim training session with a focus on interop, Superchain interops, and even more specifically building multi-chain apps and getting a little bit more in depth about how we can do that. So we'll start off with a little bit of a primer on interop, right? So what is Superchain Interop? It unlocks a network effect, right? So if we look at this diagram here, applications typically are deployed per app. But with Superchain Interop, you can access users and assets across the entire Superchain, and you only have to deploy your app once, and you can tap into these users and assets without having to basically do that per chain deployment that we just talked about. So your app will grow faster. You'll have access to users across different chains, and this is really what we're striving for.
Yeah, I think something for developers to remember is, this isn't 21, 22 anymore. It's like a lot of the solutions we're building now in DeFi, we're seeking to reduce fragmentation. So if you remember 2021, it was like, oh, billions of dollars on Ethereum, you can do anything you want there. But gas was exorbitant. So what we're doing is we're drawing some of that liquidity up to the super chain. And what that introduced is, okay, we've broken that liquidity up into 100 different places. Now what the heck are we supposed to do? And as an application developer, there's a huge opportunity in addressing many markets all at once. And what Optimism is doing, and the reason that our team builds on Optimism, is they're making it as easy as humanly possible to do that. So you as a developer, one deployment, one test suite, you're managing interactions with many chains. And what that really means is access to many investors, access to many liquidity providers, access to many users, and just a better app, which I think all of us kind of look forward to the world where every app is interoperable.
Yeah, 100%. You hit the nail on the head. Talking through some of those features, things that you mentioned, right? We're not going to have to continually go to L1 to move funds around. Superchain assets will be fungible within the Superchain, ETH, USDC, and all of the tokens that you all create. And specifically within the Superchain, our interop protocol, latency can be as fast as 1 block. And this is important because when using a dApp, latency is on a single chain, a block. So these multi-chain apps can feel as if they are working on a single chain, even though in the background you might have a multitude of chains where your users and assets are coming from. Right within the Superchain, we have every single chain abides by the same security principles and expectations. So you have consistent UX, block space is consistent. So regardless of the chain that your app is deployed against, it all just feels like one ecosystem.
Yeah, and I think a really interesting economic implication here is right now, arbitrage is one of the biggest money makers in crypto. So talk about MEV, talk about intent solving, talk about all these really high fee, high revenue domains. It all boils down to arbitrage. And right now, a lot of arbitrage takes place on centralized exchanges. So essentially Coinbase or Binance or some of these other huge firms are extracting value from the network because market makers can just sit there and arb on all the chains they're integrated with, using that as a centerpiece. And with these one block settlements across chains, what you get is more efficient on-chain arbitrage. And if you're talking about a massive step change improvement to crypto in general, especially its financial use cases, this is an insane unlock. This will really change how we think about the economics of applications and how we build applications. And I want to reinforce, and you'll hear me say this again and again, like for young developers, this is an opportunity to learn a stack that has, long-term, trillions of dollars of implication. And that might seem like a really crazy thing to say. But, once you get a stronger grasp of finance and the implication of this disruption that we're seeing from the superchain, you'll really see the opportunity. And we need more superchain developers. We need more people working on this problem.
100%. We need a lot of builders, and there's a lot of things that we still need to build and address, some of which is listed here, right? So as a dApp developer, you have the opportunity to have really easy onboarding flows, abstract bridging from your users, right? Part of what kind of hinders the multi-chain UX is the constant need to switch networks, not knowing which network you're on, where you have funds, where you don't have funds, and many more, right? So as builders come into the space, there's a huge opportunity here to basically make apps feel even more like Web 2 and just build seamless experiences.
Yeah, and to answer Slavi Karaslavov's question, I hope I pronounced that right. He's asking if there will be an opportunity for questions. So the meta question, and Slavi, yeah, feel free to ship questions anytime, and I'll go ahead and interrupt Hamdi for you so we can answer them.
Yes.
But yeah, keep going, Hamdi.
Yeah, please ask questions. So we talked about a lot of stuff, and we've made it sound easy. All these bullet points are simple sentences, but doing this is pretty hard, right? You have to use testnets, get faucet funds. Local development for this kind of stuff is pretty challenging. So at DevX, over at Optimism, we are introducing a new tool called Supersim. You might have seen a few demos on Twitter already. And what we're aiming to do is allow dApp developers to explore this space around multi-chain UX, but do it at a very fast iterative speed locally. So you don't necessarily have to go and interact with testnets and do all of those things with API keys. You can kind of just on your computer interact and try out these features for yourself. So what does Supersim let you do? It lets you simulate the superchain, hence the name Supersim. So we've built on top of Foundry. And what Supersim will do is spin up an L1 and multiple L2s. And it bakes in a lot of the experimental OP stack features that are coming to mainnet soon. Primarily, the point of this session is interop, right? So you can start to play around with the cross-chain APIs and pre-deploys that enable this. Locally observe cross-chain interactions, right? These are just EVM chains, so you can use Foundry the way you normally use it. You can use CAS to interact with the chain. And lastly, with all of this, the whole point of it is to iterate on these apps a lot quicker and build experiences that will look the same whether or not you're running it locally or you've deployed on and tested and eventually mainnet.
Yeah, and I think, to anybody listening who is already proficient in Foundry or maybe is using Hardhat and is roughly aware of Foundry, really what they're doing is they're spinning up many instances and aggregating them for you and abstracting away everything such that the experience in your test environment is exactly like the experience your users would have on chain. And thus you can test all these interactions across these instances. And anybody who's had to build a custom solution for this, which I'm sure is very hacky and hideous, should be really happy to have something like this. And as a hiring manager for software engineers, I would say, if you're a newbie, gaining proficiency here is going to look really good on a resume. So definitely dive into the repo and understand, the powers that you gain, while your senior engineer boss is building something from scratch and tearing his hair out. You can just slide in and give it this and seem like the smartest guy in the room. So highly recommended. And if you're a hard hat user, or you're even a truffle user, or you use another testing framework, our team used to be hard hat maxis. We've migrated entirely to Foundry. You have to do it. If you want to keep up with the time, there are those moments where, you're kind of on the fence, like, should I put in the time and energy to adopt this new technology? Hard hat is good in a lot of ways. It's great for deployments. JavaScript is an infinite language, but for fuzzing, for testing, you need to adopt Foundry. And really kind of astute move from the DevRel team, Hamdi, to implement this for Foundry. Are we going to see a hard hat Supersim solution, or should we just force everybody to learn Foundry?
Yeah, for all the reasons you stated, we picked Foundry for kind of like the latest and greatest, local development tooling. However, Supersim is an open project. We built it in a way such that, like, when Supersim is orchestrating all of these services, the chain is just abstracted via an interface. And the reason for that was we anticipated at some point having hard hat support, right? Or there's a new JavaScript chain development tool called Tevim, that we might be able to run Supersim in the browser using that. So the world's our oyster. We're not, we don't want to force developers to opt into very specific tooling. We, of course, by default, try to provide the best tooling, but we definitely are open to contributions and anticipate that moving forward.
Yeah, I think if there's a place to be opinionated, it's definitely in the testing framework. And every smart contract developer right now should have mastered by now the Foundry fuzzing suite. So please get on it. And maybe before we hit the next slide, Slavi asked a question. I wanted to ask you what you would recommend to someone like me who just turned 16, has been 3 years in the software development field with JavaScript, and has been learning Web3 tech with Solidity, Clarity for 4 months now. And I guess the number one thing is, your goal as someone learning software engineering is to become a junior engineer and start building real production experience. So what I would say, Slavi, is keep doing practice projects, keep honing your skills, keep developing and reading and and building up your mastery of the language. I would recommend 2 books. So book number 1, Pragmatic Programmer. So that's a book that will allow you to understand kind of the language and the jargon of professional software engineering, and give you a good idea of what makes a good solution. Now, it's not a perfect book, but what is a perfect book is what I recommend you read after, which is an O'Reilly book called Fundamentals of Software Engineering. And that is where you will learn about different architectures, their trade-offs, and what it means to work on an engineering team. I would also recommend Robert Martin, aka Uncle Bob, videos on YouTube, and really just try to get in the mindset of a professional. Because what I like to say is, when you feel like you've mastered your craft, the code, when you've become really confident in your abilities to produce smart contracts and produce software solutions in Web3 or anywhere, that's the point where you're a junior. And that's the point where you need to start thinking about, how do I build up experience? And experience is the only thing that will help you build scalable systems on one hand, and to make difficult trade-off decisions. So definitely keep pushing, read those books I recommended, and start thinking about ways you can get some professional production experience. And I would say, like, in the evolution of I'm a super confident person learning programming to now I'm a professional, just make sure you check your ego at the door. Because I don't care how cracked you are, once you get into the professional software engineering world, it's a different ball game. So yeah, and master Foundry and master testing and master fuzzing, because it's the most boring, annoying thing you'll do, but you'll be doing a hell of a lot of it. So that would be my advice to you, Slavi. Hopefully that's useful.
Yeah, great recommendations. And then just to add on to that, right, Supersim offers this infrastructure for you to play with locally. We'll talk about this a little bit in a bit, but Supersim also has a lot of reference apps, so you can kind of get a feel for how these contracts work. one of the more recent demos I recorded with tic-tac-toe. The front end is also public, so you can kind of see how to write the contracts and the supplementary front end for that game. So play around with it. Give us feedback if anything's confusing. That's very useful for us as well. So
yeah.
One
of my favorite things to do, like taking that tic-tac-toe game, try to reskin it, try to break it, try to make it do something new. Just mess around with it locally and figure out how to make your flows faster and faster and faster. Try to do test-driven development. Try to write tests for it and break them, and just use these opportunities to experiment. And Optimism has done a lot of the hard work for us here, luckily. And I would say, Slavi, like if you really love Web3, now is a great time to specialize in interoperability. So mastering Supersim, mastering kind of the Optimism stack, and really understanding how it works and the problems it's solving, I think is a really, really great way to grow into the industry, because you really need to skate to where the puck is, so to speak. You need to master the solutions that are going to be relevant 2-3 years from now. So by the time you're a senior engineer, you're not having to go back and relearn everything. So use the cutting edge, well adopted solutions like Foundry, like Optimism, like some of their Superchain interoperability stack.
Yeah, awesome. Great. So to make this a little bit more tangible, we'll kind of do a demo on Supersim. And right before starting, I just wanted to highlight we're talking a lot about interop, but Supersim is a generic Optimism or multi-chain development environment right now with a focus on interop. But it's going to be a playground for us to start introducing new features to you guys a lot earlier. And you can envision stuff around account abstraction, paymasters, etc. So we'll do a focus on interop, but Supersim is an evolving product with the main aim to make local development first class and to bring a lot of these cool experimental features early, such that as a developer, you always have a head start in the ecosystem. So yeah, just to quickly walk through, Supersim is hosted on GitHub. There's a repository for it that has instructions on how to install it. Like we talked about, the prerequisite for Supersim is Foundry. We try to offer it in as many ways as possible. You can install it via Homebrew. There's also instructions on how to spin it up with Docker. So I already have Supersim, and can you see my terminal, Justin?
Yep, you're good.
Great. So I have the repo cloned. I'm just going to run it directly using Go, but all of the commands work regardless of how you go on it. So in its most basic form, you can start up Supersim, and like we talked about in the slides, right? So it starts Supersim, configures the interop contracts. If you've used Anvil, some of this should be familiar, right? You have a available set of accounts that have pre-funded ETH. And we have our chain configuration. So we have our L1, what RPC URL it's accessible at. If you are keen to looking at the Anvil logs, you can look at the logs at this path. It also spins up 2 Optimism L2 chains, which are just Anvil chains. It doesn't run the entire protocol. It's meant to be lightweight. You can use Supersim and CI to run tests, etc. It also spits out some of the Optimism related contracts. So you have the L1 contracts like the Optimism portal, the cross-domain messenger, the bridge, etc. And this is where a lot of the experimental features will also be present. So you can see here for interop, there's a link to the explainer if you just want to learn more. But these are the pre-deploys that will be added to OP chains post interop hard fork. The L2 to L2 cross-domain messenger, which is a contract that allows you to send messages between these chains. We'll talk a little bit about the cross L2 inbox. And part of how assets will be fungible across chains is through the token bridge. And the most basic form of this token will be the Superchain wrapped ETH. So this is how ETH is interoperable between these open chains.
Nice. Are the APIs for those experimental features documented anywhere?
Yeah, 100%. So if you click into the explainer.
Oh, it's right there. Boom.
Yeah, you have the interop explainer, which kind of talks about it at a high level. And we also have our specs repo that contains everything interop, from how the actual protocol works to some of the pre-deploys, right? So the cross L2 inbox, L2 to L2 cross-domain messenger, et cetera. And this is an evolving specification as this protocol comes to life.
Yeah, and I would say to Slavi and any other young developers out there, these kind of experimental features, these pre-deploys, whatever, there are going to be a lot of systems like that are overlooked by other engineers. because when you're, a senior, staff principal engineer, you've learned 1,000 technologies, generally you're going to opt to just build something yourself. Like, I'll make a quick interface. I'll use just the core low-level message passing. So reading this documentation, understanding the interfaces really well, understanding their quirks, is going to give you the power to operate skill-wise at the level of your seniors. And that's a really great way to show off. So, lean really heavily on the open source software, understand how to weaponize it and use it in your own practice. And, you'll have your seniors thanking you all the time for putting it in front of them. So I think that's one of my favorite thing about bringing on a really talented young engineer is, obviously they've got a lot to learn, and there's, a lot of pain and whipping and torture that needs to happen before they can make, implementation decisions. But they're always coming to the table with awesome new stuff. So that's one of the greatest value adds that a junior engineer can have. And always research, because there will become a point where you just kind of become this knowledge hub for your seniors who are all like old dogs. And so definitely figure out the niche APIs. Everybody's going to be stuck in 2021 right now in the DeFi world.
Yeah, 100%. And another mode you can run Supersim that personally I'm really excited about is fork mode, where so we have Supersim. There's also another repository called the Superchain registry. So as new chains come into the Superchain registry, this is kind of like the source of truth for information about each chain. So Supersim actually depends on this registry. And you can run Supersim in fork mode, where you can just supply a list of chains. So we can see here some of the chains for mainnet. We can also, if you want to fork testnet, you could also switch the network flag to Sepolia. And just to kind of illustrate how this works, we'll fork, let's say, base mode in OP, right? So we can run fork with the chains. And this reads from the Superchain registry to get information around what are the deployed contract addresses. You can see the L2 heights that it was forked from. It also forks ETH mainnet, of course. And you get the forked chain. So if you're building a multi-chain app that has dependencies for, let's say, on Aerodrome or Uniswap, because your app does swaps in some way, you can set up your CI, or you can set up your local demo to basically interact with these live contracts without having to basically seed liquidity pools or whatever it is. And just to further illustrate that these are the production contracts, we can see here that the OP Optimism portal contract starts with this prefix, PEP5F. And if we go to our documentation around what are the deployed contracts for OP mainnet, we can see the Optimism portal shares that same address. One thing to note, though, is that the public RPC URLs are rate limited. So if you run into issues there, you can set your own specific RPC URL. So you can run Supersim in just vanilla mode, just spins up the chains, but you could also fork networks and basically interact with them as if posted.
I think another important call out for people building omni-chain solutions is understand the create3 opcode and or the create2 opcode, so that you can create the same address for your system on every chain. That's going to be really important to prevent scamming. That's going to be really important just for ease of use for users and developers. So, I see that prefix, I see the zeros afterward, I know that this is what we need it to be. And, obviously it can take some time to compute the address you want. But for example, we just deployed on Base our stablecoin CDXUSD on Aerodrome, and on every single chain, we've structured it so that it's going to be OXC0 D3 and then 7, which is technically leak code for X, and then 00000. So users will always know they have the right address because they would need our private key. They would need every aspect of the deployment to be exactly the same to achieve that, which would not really be possible. So definitely learn create3, and it will make everybody's life much easier.
Yeah, 100%. Those are very powerful primitives. Cool. So let's walk through some sample commands. The first thing I'll do is illustrate that, a lot of the OP stack features are simulated in the same way that they would work on production or testnet. The first one is we have the Optimism portal contract. So if your app depends on deposits, we can set up a deposit. So let's go ahead and deposit some funds into OP Chain A. Gonna just write out the commands, no copy paste. So if there's any issues, bear with me. But
no mistakes allowed.
So we're gonna go ahead and send a simple Ether to this Optimism portal contract address for OP Chain A. The network we'll be sending it to is the RPC URL for L1 because this is a deposit from L1 to L2. And we'll be sending it from just one of the private keys. So we can just go ahead and copy one of these generated ones. So we know all these keys have funds in them. Cool, so we can send off this transaction. And we can see here that Supersim detects that a deposit was observed on L1 and it forwards you can see the transaction hash on L2 for that chain. So if you wanted to, you can, let me clear this out. You can observe that transaction hash on L2.
That's awesome that you just did that so fast. That's crazy.
Yeah, that's the whole point. We want this to be as fast and as seamless as possible. So we can give it the transaction hash on L2. We can see if that deposit had any sort of, if you're invoking a deposit on a contract, you can observe its logs and its behavior. Last thing we'll do is just show that the deposit worked by querying for the balance of, we use this private key, so we're going to query for the balance of the corresponding public key. And we'll be doing it for that L2. So 9545 is the RPC URL for OP Chain A.
Nice. I wonder if there's a way to shove these RPCs behind variables when they're initialized automatically, so that you're not, calling localhost 9545, but rather calling base RPC.
This should be HTTP. Cool. Yeah, and we can see that Ether was sent to that balance.
Oh, hell yeah.
Cool. So that's this is a OP stack feature that has always existed for deposits, and we'll get into the interop specific flows. So the reason I'm stopping Supersim and restarting it is because I want to enable the auto relay flag. The reason for this is if you don't enable this flag, if you're sending a cross-chain message, you have to have some sort of relayer to basically bridge that message to the destination chain. You can do that yourself, and there's actually integrations with Supersim. Hyperlane put out a PR that was merged into Supersim, and if you would like, if let's say you're a developer that's using the Hyperlane SDK, today they have support for the Superchain Interop APIs. And if you're using that, you wouldn't supply the interop auto relay flag and rely on the Hyperlane SDK to take care of that for you. So that's also available, but to make that first step of development really easy, we have the auto relayer such that when you're sending a message, Supersim will just take care of relaying it for you on the destination chain. Great. So what we'll do is simply interop some ETH from chain A to chain B. So the first thing we'll do is wrap some ETH into our Superchain wrapped ETH. So we can go ahead and do that. So we'll send the same Ether to our Superchain wrapped ETH from, let's use the first private key. Great. And just to verify that we have some wrapped ETH, we can query the balance for that address on chain A. So we'll query the balance, and the balance we'll be querying it for is that first account.
Wow.
So we see here we have some wrapped Ether. So now let's say you're a developer, you want to use a token bridge, but you don't exactly know how it works. We referenced the spec, right? So we can look at our pre-deploys. We can go to the, let's see, where is the token bridge? Superchain ERC20 bridge, specifically the send ERC20. So any token that adheres to the Superchain, let's go back. We have I guess maybe the spec for this hasn't been published yet, but there's a interface for how a super ERC20 is defined. And as long as the token adheres to that interface, you can basically interop that asset between any two chains in the superchain. And the way you do that is through the send ERC20 function on that bridge. So we'll just go ahead and invoke this, right? It takes the token address, the address you'd like to send it to, the amount, and the chain ID. So we can go ahead and do that.
Is this interface being adopted at all by other bridges that are on the Superchain?
That's a great question. So we are working in public, and these interfaces are very minimal. And the idea for that is so that token definitions don't have to be locked in specifically to the superchain. If you want a token that can interop with that 1 block latency within the superchain, but let's say it's also a layer 0 token that interops between different ecosystems, you can have the same token contract that can basically move around depending on however that token contract is implemented. So it's an interface, meaning you can implement it to behave however you'd like.
Interesting. Yeah, that's awesome.
So we'll go ahead and this is the function signature for the bridge. Great. So we're going to interact with that bridge. We're calling the send ERC22 function, which is, oh, I guess there's no 2. It's a good thing I checked.
I was about to say, like, oh, Hamdi knows better than me.
Yeah, so we're calling send ERC20. We have 2 parameters, which is the token address and the destination address, and the amount and the destination chain, right? So we have all of the parameters here. We can go ahead and list them all out. So we're going to be interoping the superchain wrapped ETH. We'll be sending it to the same address on the other chain.
I like how you're making interop into a verb.
Yeah. And we'll go ahead and interop the entire balance. And we'll send it to chain 902, right? So we have the 2 OP chain A and OP chain B. Oops. And we have to specify the private key for this account. Great. So we should see some logs here. I wonder, here, let me query this balance on the second chain. I know what I did wrong. We have to specify the RPC URL.
I hope everybody is listening, because you're going to be making these same mistakes.
Yeah, great. So we basically triggered the transaction on OP chain A. I think this sent the transaction. The default address in Foundry is 8545, which is L1, but there's nothing that happens on L1 because there's no interop APIs there. Great. So we've sent that transaction, and we can see that Supersim emits some contextual information that we can see on chain 901. There was a burn event which removed that balance. And if we were to query the balance on that chain, so 9545, we see that the balance is 0. The token bridge contract is secured by the L2 to L2 cross-domain messenger. So you can use a messenger to send arbitrary messages, and the bridge uses that contract for its own purpose of interoping assets. We see a message that was sent on chain 901. Whenever there is an interoperable event consumed on the destination chain, Supersim basically ensures the invariance for that interop message. So if you're a builder writing a relayer, you can be sure that if this fails, that there's some bug in your relayer that you'd have to fix. You wouldn't want any silent failures. And then the auto relayer will relay this on the destination chain. So we can see the relayed message event on to the destination chain 902, and then the corresponding mint that occurred. And then at the highest level, that the Superchain token bridge said that, hey, some asset was relayed. And we can query this balance on 9546 and see that now that same address, which had that 1 wrapped ETH on OP chain A, now instead has it on OP chain B. Sorry, were you about to say something, Tristan?
Yeah, so I saw you didn't get logs when you didn't put the RPC URL, private key, etc. What can users expect in terms of error handling for Supersim right now?
Yeah, that's a good point. There's in my experience with Anvil, sometimes if you send a transaction to a contract that doesn't exist, that contract still succeeds. So one, if you're encountering an issue, if you're encountering any problems, raise an issue in Supersim, and we can figure out how to best basically address that for our users, whether that means a PR onto Anvil or just like on our end, okay, you're sending it to the wrong there's no interop contract on L1. They're all in L2s, for example.
Cool.
So when things do go wrong, Supersim will tell you, but there are going to be corner cases that we might miss, just like I demonstrated here.
Yeah, I think like, anytime you're dealing with OSS in general, I think a big thing for people using it to understand and a big mindset that is great to reinforce is when you see something that is weird, or that you don't like, or let's say an error isn't handled properly, let that be an alarm in your brain saying, I need to go on GitHub and either raise an issue or submit a PR to fix it. Because the only way we're going to advance this technology is if we do it together. And to Slavi, to answer his question from a little bit ago, he talked about how can you build out a network of developers. Submitting PRs, joining the open source community, raising issues, raising questions, etc., is a fabulous way. There are so many teams that hire from people contributing to their repositories in the open source domain. I mean, I would say as well, Slavi, keep going on X, be a reply guy, grow your account, talk to all the DevRel people, get involved, and also look for Discord communities or Slack communities. There's Empire hacking. I remember in the old days from Trail of Bits. Look for fellowships. Early on in my career, I was in Kernel OX, which I think they're still running. That was way back in 2020. So yeah, just look for opportunities like that. And he's got a follow up. I see that Foundry and Optimism's docs use the same template. Is there any work for content writers at all anymore? I will say, there's an endless supply or an endless need for documentation. I think the tough part is prioritization. Maybe you can speak to that a little more, Hamdi, as far as Optimism's appetite for technical writers.
Yeah, I think you mentioned the word template, right? They're just templates, but there's still a lot of content that needs to be written. And we have our Supersim docs pages. It's also hosted using the same template. And we'll talk a little bit about this in a second, but write good reference examples, make it really easy for users to follow, and copy paste commands and get a feel for how this all works. So we're always open to also adding content to these docs. So if you're reading documentation, you're like, oh, this could be better explained in this other format or way, feel free to open a PR or issue asking, hey, this is my perspective on this, and we can start a dialogue and get some more contributions added to the docs page as well. So the templates don't write themselves. We still have a lot of work to do to get readable, digestible information in them.
Yeah, and our team runs apprenticeships all the time. There's a boot camp called bcamp.dev that's free that we highly, highly recommend. We recruit apprentices from there for additional training. So bcamp.dev, I'll show them real quick. It's like a labor of love and they've received an Optimism grant in the past, and they have worked with Mode and are all around the Superchain. And then if you see our intern Dex in the audience, he recommended you join our Discord, and I'm not going to chill it because this is Optimism's thing, but we help a lot with people learning DeFi development. So would love to answer some questions. It's like a collective effort figuring this thing out because it's a very nascent industry and there's a really long way to go.
Yeah, it takes a team, 100%. Awesome. So we just showcased the most basic form of interop, which is sending assets cross chain. But as a app developer, you're going to be writing your own apps. So there's two examples I want to walk through. One is how do you leverage the L2 to L2 cross-domain messenger to send messages in your app between chains? And the second is unique to Superchain Interop, which is like how can we build a multi-chain app that doesn't actually require any message passing? Which is a little bit more advanced, but I think is like really the frontier of the space. So the way we'll start off with the easier one, which is like sending cross-chain messages. This is what every interoperability protocol offers. Have a destination chain, some call data that you want to invoke, and then a relayer that probably bridges that message. So the way we'll showcase the first example is through a contract called Ping Pong, right? As the name might illustrate, it exists in the Supersim repo. We'll take a look at it. But the idea is pretty simple. There's this contract exists on every participating chain, and there is a designated chain that can start the first serve. and that chain can basically serve the ball to any destination. The destination will receive that ball, and they can then hit it to any other chain. So in vanilla mode, we only have 2 chains, so we'll just send the ball back and forth. But if you had 3 or 4 chains, you could basically send the ball to different parts of the network. And so what this contract looks like, I have it open here. We have our cross-chain ping pong contract, right? When you create the contract, there's member chains that are allowed to participate, and then the chain ID that is the first server, right? So if someone tries to basically, sorry, let me just skip that. So yeah, cool. So we have our participating chains and our server chain ID. And then the starter chain can basically serve the ball to any destination. This is where the cross-chain part comes in. So we have this ping pong ball struct, which has a rally count so the number of times that the ball was hit, the last chain that hit the ball, and then the last address in that chain that hit the ball. So we can construct a new ball that has, this is the first count, the chain, and the sender. And you can send a cross-domain message to that destination. And if we look at that function implementation, right, this is where we have a function here, receive ball, that the only person allowed to call it is the cross-domain messenger, right? It basically enforces that this, no one can just call this function to receive the ball. It has to be a cross-chain message. And this is the structure of the same function signature, right? The function selector, which is the receive ball, and all the arguments that it exists. So we have that message that's encoded, and then we can simply send that message to the desired destination. And this contract exists on every chain, right? So the destination address is just the contract itself. This is just what you're mentioning, create 2, create 3. This contract uses create 2, so it has the same address on every chain.
Awesome.
And yeah, so it sends it to itself. And on the destination, when it's relayed, the messenger will unpack this, invoke this message call data on the contract, which is simply receive ball. This sets some fields like the ball is present on this chain, emits a few events. And then once you have the ball, you can then hit the ball to any other chain. And that just follows the same series of steps where once you've created a new ball, you delete the receive ball, which means that you're not allowed to, the ball is no longer present on this chain. So if you're to call it again, it would not work. And then it calls the same send cross-domain message to basically send the ball to the specified destination.
Awesome. And maybe that was a lot of code. I'll boil this down a little bit for people. So essentially what you're doing is you are creating a system through which calls and callbacks can be handled off-chain really easily, being now you have a test framework or an app that's detecting events on both chains and thus can react accordingly. And I think, one place I see the design space going, there's always when systems get mature enough, there's always an engineer sitting in the back. It's like, hey, what if we added callbacks? Or, hey, what if we added hooks? Something that's really interesting me in terms of design is seeing what these on-chain callbacks look like for these omni-chain apps. So right now, what you're building with Ping Pong is an amazing omni-chain application. But what does an omni-chain protocol look like? And to maybe get a little nerdy with it, I think the goal in reducing fragmentation is to make specialization a more reasonable pitch to blockchain networks. So right now, what specialization would mean to a new superchain is potentially sacrificing market share in a lot of high volume or high revenue domains. So think about decentralized exchanges, lending, any of the big ticket items in crypto. And, what I think people are going to start doing is, because these interoperability solutions are going to get more and more seamless, thinking about how each chain fits as an individual processor within the greater system. So for a very practical example, I'll give 2 chains. Base and Mode. These are two networks that our team builds on extensively. So Mode has a really exciting new DeFi community. There is a lot of interesting projects. There's a lot of unique projects. But the issue is there's not a ton of market liquidity. So when you're talking about things like liquidations, things like arbitrage, it's not as profound as you want it to be, but it's a great ecosystem nonetheless. So you look at Base, you'll see what's happening on Base. A huge amount of liquidity, a huge amount of volume, one of the most liquid centers of capital in the entire ecosystem. And right now, they're totally separate. But what happens when you can create systems through which Mode can use Base as a co-processor for settling swaps? So now Mode doesn't need to think hard about market liquidity. They don't need to pay out the nose to onboard capital and onboard traders, whatever. Instead, they can specialize in, for example, lending or in derivatives, or a chain could specialize in NFTs and then create an interoperable solution using on-chain calls and callbacks to turn Aerodrome into essentially a liquidity coprocessor. And it works effectively the same as this on-chain ping pong contract, where you need a way to take asset one, bridge it, make sure there's gas in the equation, swap it for asset two, and bridge it back. And then you've essentially performed a swap without needing liquidity on your chain. And I think that is going to be a huge design unlock for these new entrants coming to the network. Like Superseed is a brand new Superchain network, and they're going to have this awesome stable coin. They're going to have all these cool lending teams, but they run into the same problem where they have this amazing ecosystem of derivatives, but market liquidity is very competitive and hard to ascertain. So especially for niche pairings or niche liquidity, go to Base, go to Aerodrome, and create these interoperable solutions such that users don't need to leave your chain. Users don't need to go elsewhere. They can instead just borrow from these other sources of liquidity. And that to me is like going to be a massive step change improvement in the developer experience, in the user experience, and in kind of the business experience or the B2B experience of people looking to build super chains.
Yeah, 100%. And that kind of highlights the first kind of application that uses interop, which is very push-based, right? You're sending a message from one chain to the other. I'm going to quickly run through this contract deployed and interacted with. And I know we're getting close on time, but I really want to touch upon a scenario which you don't even have to do pull-based interop. You can do push-based. You would instead do pull-based, where you just react to any Ethereum event on a different chain. So right here, we have a forge script that deploys a ping pong contract. We're going to deploy it to OP chain A here. And we can see that it's deploying it to this contract address. We'll go ahead and deploy it to chain B as well. So just swapping the RPC URL. So we have the contracts present. The way the deploy script is set up, chain A is the first contract to serve. So we'll go ahead and just copy the contract address here.
This is awesome.
We'll send to that contract, and we'll call serve. I believe it's serveball 2 with the chain ID. Serveball 2 with the chain ID. We'll pass it to chain ID OP chain B, which is chain ID 902, and we'll just send it with just some private key. So we'll use this one right here, and we also need to specify the RPC URL. Private key.
The server returned. That's really funny. Unfortunately, they didn't return what we wanted them to.
This is the deployed at this contract. Cast send. We're invoking the, oh, that's why. The function signature is incorrect. typically when
Oh, I was gonna call that out. Oh my gosh, dude, I'm
Yeah.
I'm the worst. I'm the worst pair programmer ever.
No, you're
I'm like
totally,
UN56. I've never seen someone use UN56, but I trust Hanzi.
yeah, you're totally good. But we can see here that we don't have the superchain with stuff because we're just using the superchain or the L2 to L2 cross-domain messenger directly. We can see a message was sent on chain 901 to chain 902, and if we try to invoke that contract again, we'll get a revert, and this is the revert code about the chain not being on that, the ball not being on that chain. We can send it back. So instead we'll start from chain B and we'll send it back to chain 901, 9546, serve ball 2.
We're turning interoperable into a verb, and we're turning the action of building interoperable solutions into a sport. So you better practice, guys.
And this issue here was that once the ball is served, you have to hit it.
Ah, nice. Okay, cool.
Great. So, we've sent the message and then we sent the ball back. So we just basically done these two events. So this is very much push-based cross-chain messaging, which is what people are most familiar with because that's what's offered on the market. However, Interop also allows you to do something unique, which this is where the cross L2 inbox comes in. And what it does, and this is how the L2 to L2 cross-domain messenger actually works under the hood, is that we're going to kind of take a little bit of a step back and talk about fundamentally what's happening here. So any contract can emit log events. So we have some event here. And any contract through the cross L2 inbox can basically pull in that event on chain, right? And the rules is that, chain B must be in chain A's dependency set, aka the superchain. And the ID and the payload of that event must match the ID to that log. And if we just quickly take a look at what that means, right? The message identifier is simply uniquely identifies any Ethereum event. So the contract that emitted that event, the block of that transaction, the log index, the timestamp of the block, and then the chain ID of that log, or the chain that produced that log. And then the message payload is just simply the serialized structure of the log, which is all the topics and then the log data. So now what you can do is you can write contracts that you no longer have to push anything. You can just be a consumer of Ethereum events. So to give a concrete example, let's say I have a contract on OP mainnet and Unichain has so many pools that were created, and I simply want to have some sort of consumer on my contract that can react to basically pool created events on Unichain. I can basically write a contract, have a function that basically, as pool created events are emitted on Unichain, you can basically push them into chain A, unrelated to Unichain at all. You can just keep those events together. And the application that kind of demonstrates how this works is the tic-tac-toe game. And this game,
and is that powered by a relay layer that's initiating the calls back to chain A?
Great question. So if you're purely using this feature, there's no relayer at all, because let's say this event has occurred, anyone can basically push that message to chain A. I guess you could use some sort of relayer if you want some sort of continual push mechanism, like a pool is created, push that event to chain A. Another pool is created, push that event to chain A. That could be a relay message, but there's no corresponding initiating. It's just every Ethereum event becomes consumable by any other chain in the dependency set or in the superchain.
Great.
And if you watch the tic-tac-toe demo, this is exactly how I built the tic-tac-toe game, where there's no cross-chain messaging. The tic-tac-toe contract emits the new game event, and anyone in the superchain can basically react to that new game event by accepting it, and then a series of moves that can be played in the game. And just kind of showing how that works, right? These are the events that basically define the ordering of the game. And we can see here that there's no messenger, there's no relayer. Simply, when you create a new game, you simply emit this event, the new game event, and it has information about the game that's required on the opposing player to basically hydrate its local view of the game. And to accept the game, you simply have to provide that identifier to that new game event as well as the payload, right? So we use the cross L2 inbox to basically validate that this is the correct payload for this identifier. And this is what the sequencer hooks into, so that when it's building the blocks, if someone called this function with an incorrect payload or an incorrect identifier, that transaction gets emitted from the block. And then we have some cases, right? Similar to similar to ping pong, this tic-tac-toe contract exists on every chain. So the origin, the contract that emitted this identifier, has to be the tic-tac-toe game, and then we can decode the data for that log. So we see here in the new game event, we have the chain ID that originated the game, a unique game ID for that game, and then the player that initiated that new game event. And the player can accept the game. So this is like local to the player's chain. There's no message. It just reacts and says, okay, I want to play this game. It emits the accepted game event. And then the original player that emitted the new game event, or like called new game, can then simply point to the accepted game ID, right? And then when a game is accepted, it also makes a move. And this simply like sets up the local game state on that chain and then emits the move that they played. And then both players just simply keep on making moves. And the only way you can make a move is if you have a newer event that your opponent has played, right? So the move has to be forward progressing, meaning that once the player has made a move, it can no longer make a move until its opponent also makes their moves, and it has basically a new move played event that it can provide to this contract. And that's what sets up this kind of like back and forth without any messages being sent cross chain. The player on this OP mainnet chain can just send transactions to their chain. There's no need to switch networks. And then the mode player also does the same on their network. And one fun fact, I guess, if it's a fun fact, is that every chain is by default a part of its own dependency set. So even though it seems like in this contract, right, it's innately cross-chain, without changing any of this code, this chain can observe logs emitted of itself. So players can play regardless of whether they're on a different chain or the same chain.
Wow.
Does that make sense?
It makes some sense. This is like, if you were to tell me you were making this in 2021, I would be like, what the heck? That's like, when I'm smashing rocks together and you're, rolling out a wheel for the first time. I wanted to surface Crypto Kook's question.
Yeah.
In the demo, we did not see the second transaction because auto relay took care of it. Is that right?
Yes, 100%.
Very dope.
Yeah. So if you don't have auto relay enabled, you can relay the message yourself, or you can use an SDK like Hyperlane to do that for you. Or if you have your own backend and you want to take care of relaying transactions for your users, you can also do the same as well.
Wow. Okay. So, all right. So now we're going to be building these event-driven relayers to app-specific. Oh, dude, the vertical integration potential here is crazy.
For sure.
I'll say, like, if you're developing an application right now, or you're a software engineering firm, whatever, like, build an in-house solution ASAP for event-driven relaying. Because imagine the cost savings opening that design space up to developers. That's crazy. I did not realize that was possible. That's like actually insane.
Yeah.
Wow. I mean, props to Optimus. I mean, there's a reason that I think developers are coalescing around OP. It's like, from a technical perspective, you guys are killing it. And then, from an ecosystem perspective, it's like, just as a function of that, you have all the dependencies, you have all of the infrastructure, all the tech. Amazing. That's cool.
We might go over like 10 minutes, but I want to quickly show this tic-tac-toe demo.
Sure. Yeah, I will. I'll let you cook, Hamdi. Thanks a lot.
No worries. So what we'll do is similar to ping pong. We'll deploy the tic-tac-toe contract on chain A, and then we'll also deploy the tic-tac-toe contract. So this, we're not going to use cast. We actually have I recorded a video on this, so you might have already seen the game. But we have our contracts, and we also have our examples folder. Oops, that was not the right. Cool. And then in the examples folder, we have our tic-tac-toe front end. So we can start the front end. So what I'll do real quick is just have the contract side by side so you can kind of see what's happening here. And I'll just go through the new and accept game flows, and then the demo kind of shows everything else. So we can access the demo here. So I guess let me quickly, you can connect your wallet. We have all these pre-funded test accounts connected. We can make sure that this account, let me just clear this activity because the nonces might mess up. Okay, cool. All right, let's just connect to test account 1. Okay, cool. So we have our pre-funded account. This player is connected to chain 902. Let me just switch that to chain 901. And this so there's no relayers here. This person's just going to emit a new game event. This needs to be non-zero. Oh, actually not. And we can see here that if we look at the transaction, like the contract doesn't do anything besides emit this event. And then it has a counter for the next, like a game ID unique for that game. And any player, let me open up a new browser. Right, so we'll do the same connect flow. Great, so we'll connect some more accounts. Great, so we have 2 different players. This is the same wallet, so let me just switch to taste account 2. Right, so this front end is listening. If we go back to this diagram, this is an example of an app that looks like this. So this app is listening to events that occur in the entire superchain, and it's saying, hey, there's an event that hasn't been accepted yet, and you can accept it. And this is where this accept flow comes in. And the front end for this is in the Supersim repo, so you can kind of look at how this works. And all the accept transaction does is it refers to the new game event. And this is where in this Excel draw, right, this is the consensus rule that this event has to be correct. Otherwise, the transaction doesn't make it in the block. So let's go back to the game. This player can accept this game. And if a new chain ever gets added to the superchain without changing the front end, the person can just run the deploy script, right, on that new chain. And then it just, like, the app just works. There's no need to set it up per chain. And we can see here that the game has started. I'll go ahead and make a move. Right? This move refers to, if we go back to the contract here, when you accept a game, it emits the accept game event. So when you start the game, it refers just to that event. So that's what that does here. And then this is where the make move function comes in, where they just basically keep making moves against each other.
Wow.
So when you accept a game, you make a move, and then you can basically continually make moves. And just to showcase that the contracts do work as expected, I'm going to open the front end real quick. All right, so we have our examples folder, tic-tac-toe. We'll go to the board component. So I have a nice little thing, like if it's not your turn, you're not allowed to click any. Oh, I guess I already changed the code. So it's your opponent's turn. Okay, yeah, so if it's your opponent's turn, there's this nice like overlay that doesn't let you click anything. But what I'll do is just make it so it's clickable, and we'll see the contract. The contract will, so now everything is clickable. Let's open the logs. Let me, how do I know? Okay, so we see here if I click any move, it says that the move is not forward progressing, because when it tries to, like I've made my move, and when it tries to basically make another one, it refers to the same event of their opponent. So there's no forward progressing move that this player can play up until their opponent makes a move. And then once their opponent has made a move, the front end will, consume that event and be like, okay, now there's a move that you can play, and then you'll be able to send a transaction as expected. So this is where the ordering kind of comes in, where every time a move has been made, we record the last identifier that was consumed, such that it always has to be forward progressing in the game. So yeah, there's no relayers at all. It's truly on the chain, right? In the app here, just for demonstrative purposes, we have the chain that the players are playing on. They could play on the same chain. But if you're building a production dApp, what this primitive allows you to do is completely remove the chain. Just connect your address. The wallet, the chain that which you have funds on is the one that you play on. And you can interact with any other address. So that was a pretty quick rundown. I know there's a lot of information. I could stay on for a little bit and answer questions. But yeah, that's like I think the frontier of interop, where it's this primitive that is unique and no other interop protocol really offers, because most interop nowadays is just this push mechanism, not like a pull-based reactionary mechanism.
Yeah, that's like amazing. It's exciting to see that a lot of the stuff that we were talking about in EIPs and arguing about in forums a couple years ago is now becoming a reality. Did you build all this yourself, Hamdi?
Yeah, I did, and I use Cursor,
Dude.
so I highly recommend
Yeah, beast.
using trying to get into the space. Definitely use AI to your advantage because it helps do all this.
Amazing. Yeah, really, really fabulous work.
Yeah, awesome. I'll share my screen for a little bit in case there's questions about the code. Otherwise, I can also stop and we can chat.
Sure. Yeah. I mean, I think we've run out of questions here. Last chance, last call for the viewers. If you have anything you want Hamdi and or myself to cover before we close up shop.
Cool. Awesome. And that was a lot of information. There's going to be even more material, content, videos, demos to kind of make this a bit more digestible. Please ask questions. I think there's also a Telegram group that you all can jump into as well.
Yes, that's what I wanted to mention. We'll publish a Telegram group so that any app developers that have any additional questions can jump in and ask them, and we can provide more documentation or anything it is that you need. So I will publish that Telegram link maybe in the tweet thread. And yeah, feel free to join it. We're building together forever. Thank you, everybody, for joining. Thank you, Hamdi. Thank you, Justin. This was a wonderful conversation. And that's it. Enjoy the rest of your day.
Yeah, special thanks, Justin. Man. Really appreciate it.
Yeah, thanks, Hamdi. Thanks,
Justin.
Amanda. And I'm sure we'll talk soon. Bye.
All right. Bye, everybody.